Hello friends, just after some time after the Big Bang, I mean very little time after the Big Bang, because after 3 seconds the thing I'm going to talk about right now is going to finish, but just after a little time after out from the Big Bang, light had so much energy that when two wavelengths of light collided, it formed a particle and its antiparticle twin. Right here, this is an electron in normal matter, this is an electron in antimatter or positron. Well, after 3 seconds after the Big Bang, all this finished. But what if this copy was made of antimatter? Well, this copy won't be a copy right now. This copy would be a bomb right now. You see, matter is an excitation on a field. Antimatter is a mirrored excitation on that same field. And as we all know, these two excitations will cancel each other out. They have the same energy, same spin, but their charges are different. So, if these two collide, they will cancel out. But that means, the mass and mass contained in these two excitations will just disappear. But that physics doesn't allow that. What happens is that this waves goes silent. This field is now neutral, but it has caused excitations on the photon field, leading to photons and a lot of energy. So this copy won't be a copy. Antimatter could not exist in a universe of matter. So in the first time of the universe, first seconds after the universe went boom, and the producing of matter and antimatter stopped. All matter would have found its antimatter twin and just boom, they would have annihilated or cancelled each other out, and the universe will be full of radiation like a light and other types of energy. But nope. The universe is made up of matter. Every galaxy we have already seen, every planet, every star, every rock, every human, every phone, down to the tiniest atom is made up of matter. Whereas the antimatter gone. We don't know that. That's why antimatter is the most expensive thing in this universe. It costs trillions of dollars, and there isn't much. We have already created an anti-hydrogen atom with a negatively charged muon and positively charged positron. We have already created an anti-hydrogen atom, but it lasted for fractions of a second. No, not enough for scientists to study it. But we have already managed to trap antimatter in a box and ship it. So that's a good start. Let's now know the names of what antimatters are called. Protons have positive charge in a world made of matter, but in a world made of antimatter, protons have negative charge. But we don't call them protons anymore. We call them muons. And electrons in normal matter world, they are negatively charged, and you have guessed, in antimatter world they have positive charge, and I think you have already guessed their names because I have already told you their names. They are called positrons. Now, well, okay, maybe the matter got lucky and made the universe of matter, but where is the antimatter then? Well, if every matter in this universe survived that universe, then where is the antimatter? Because every matter needs to have found its twin, and if it has not, where is the antimatter? Still located in the universe? Well, these matters might be lucky, very lucky, very. All its other matters could have been just annihilated, and all the things around us would be made up of very, very, very lucky particles. But if that, there must be very, 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 very lucky antimatter particles. Where are they? Well, you might have think that, well, there might be antimatter galaxies with antimatter stars, with antimatter planets orbiting with antimatter humans, with antimatter phones, with antimatter atoms, but we haven't still found them because they must have a little bit interacted with matter, and we should have seen bright spots in the sky, but we haven't. So does antimatter exist? Yes, we could make it. So it also exists because we have already made it. And have you ever discovered antimatter? Yes, we have discovered a positron by accident. And well, have we ever discovered antimatter in the sky or naturally? Nope. That's, well, we don't know. Is there antimatter or not naturally? But there must be. And I think if you really love astronomy, in someday in the future you might discover antimatter. So happy hunting in the future, and for now, thank you everyone for watching my video.